Okay, let's hear where we stopped last time, and I'm going to scroll back. I think we stopped in this graph over here. And again, it's important that when I do the graph that you also see in the answer key that I list the answers for you, and you check those answers to make sure they're correct. All right. So the point of this over here, this graph over here, there's no numbers on it. Now, granted, you might say, oh, this one's obviously x equals 0, but it's not obvious what y is. All right. So we had to figure these points out over here, and we did that one at a time, and we saw a pattern to it, and we filled out the table. All right, I'm going to go back to the whiteboard, and we'll start problem number 50 now. Again, notice a long review, but the process of learning is going back over old material to make sure you understand that old material. So I'm going to give another share with you. I'm going to share the whiteboard with you now. Let's take a look. So I'm going to start with problem number 50. All right, push it on the side. And what I'm going to do first, at least initially, I'm going to, certainly I know they want the equation of an ellipse. And I have to, draw a picture of what this thing would look like. And I'm not saying I have to draw a picture. I'm just saying it may be a good idea to draw a picture of what this thing would look like. And what do I know about it? I know it has vertices at plus or minus 8 along the y-axis. So I'm going to say, up here, this is the point 0, comma 8. And then there's a point down over here. Let me extend this a little bit. A point down here that's, 0 minus 8. All right, and they're the vertices. Right, what are the foci? Well, along the y-axis, of course, and, one here and one over here. And what are those points are going to be? Well, this point over here can be 0, 7. And this point over here is 0, minus 7. I'm going to draw what appears to be an ellipse through that. And I'm going to say something like this over here. And again, it doesn't have to be a great picture, but I know the major axis, that's where the vertices are along that. All right, so I'm going to start writing information down about this. And the information I want to write down is, I know it's an ellipse. They said it's an ellipse. And I'm going to start write that down information, certainly the center. And what's the center? Well, clearly looking at it, it's 0, 0. All right. So what do I know about this? I know it's going to be x minus 0 squared over something plus y minus 0 squared over something equals 1. Now, I want to say that some of these things are easy to figure out because 2 points on the ellipse. And I just want to point out, I know this point and this point. Whoops, sorry about that. So I know these 2 points. So I'm just going to plug it in. And certainly if I plug in 0, 8, what would you get? Well, I have to send that x is 0, right? So if x is 0, I want to emphasize this term, whatever it is, would disappear. But if y is 8, this would be 64. All right, this top would be 64. And it's got to be equal to 1. So the bottom here must be 64. I'll put that down for you. So how do you get the other one? Well, you don't have any other points along the ellipse, but what you do know is that this foci is 7 units in from the center. So I know that C is 7. And again, it's 7 units in from the center. All right, 7 units in. Now, what do I know? Well, let's write this down. So C squared is going to equal that 64 minus this thing. All right, let's see if we can do that. So C is 7, right? So what's that? 49 equals 64 minus a squared. By the way, some people say they want to use a different letter for that, like an x or whatever. Don't use x because x is in the problem. You could use A, B, don't use C because we already have C down, D, whatever you like. We're just trying to figure out what that number is. So what do you get? Let's see. If I took 64 from both sides, what would I get? I get 25, right? Minus 25. So what does that say? A squared is 25. Let's go back up there. I'm going to put my eraser out. Erase this over here and put down 25. I'm going to clean it up a little bit. And what do I mean by cleaning it up? I'm just going to write it so it looks a little bit neater, and then we'll check the answer key. So what does this look like? X squared over 25 plus y squared over 64 is equal to the number 1. Again, my emphasis is looking at the answer key to make sure that they have that in the answer key. And I see that right there. All right. So number 51, that's write an expression for the nth term. Let's take a look at it, and I'll write this down for you. So this is 51, and I'll write down A1 is 2. I'll write down A2 is 1, and I'll write down A3 is 8/9. I'll write down A4, and this looks crazy. I mean, how did that happen? And then, that's 1, it's back to 1 again. And then, I got 1, 2, 3, 4, I got 5 now, right? Equals 32 over 25. Well, my goal over here is to write these down, and I'm not saying I'm going to be good at it. I want to write them down so they look like they're related to one another. And I'm going to write this over here. And I'm going to say this one, 8/9 is certainly related to 32 over 25. And what I've got to do is I'm looking at, I chase one route at a time. I'm going to look at the bottom number, 9 and 25. And I'm going to say they look like perfect squares to me. 9 is a perfect square, 25 is a perfect square. So 9 would be 3 squared. And that makes sense to me because I'm seeing a 3 here and I'm seeing that would be 3 squared. And this, whoops, that doesn't look like a 5, does it? So I'm going to point out again, this is 5, this would be 5 squared. And again, maybe it's not right. This would be 4, what would be on bottom? 4 squared. Let me write that down for you. Again, I'm not saying it's right. I'm saying I think it might be right. And that would be 2 squared, which is 4. And this bottom would be 1 squared, which is 1. Now let's look at the top number. And again, I always say chase one rabbit at a time. And I'm looking at it, and I'm looking at the two numbers. I want to point the two numbers I'm looking at. I'm looking at 8. How's it related to 3? And I'm looking at 5 and wondering how it's related to, I'm sorry, I'm looking at 32 and related to 5. I'm going to say it looks like 2 to a power. I put this over here. This looks like 2 cubed. This looks like 2 to the 5th power. So what would this one be here? 2 to the 4th power. Let me write that down for you. Again, I'm believing that. I'm not saying it's right. This would be 2 to the 2nd power, and this would be 2 to the 1st power. Well, I'm looking at it one at a time, and I'm starting to say, you know what? It matches up. That same thing as 2. That's the same thing as 1. Well, this was the same thing because we wrote it down. What's this thing? 16 over 16, which is 1. And this is 32 over 25, which is a given. So now I have it. I'm going to write this down for you. So AN, again, I'm looking at it. It looks like the bottom would be n squared. Right? We've already figured out the first rabbit we chased. And the second rabbit was 2 to the nth power, with the understanding that n is starting at 1. So n starts at 1. All right. Again, my emphasis is look at the key, and I hope you realize, you're seeing that answer over there. All right, let's go to the next page. We'll go to 52 now. Wow, where's that? Oh, I'm sorry. I must have inserted a page. All right, deja vu all over again. It's actually a geometric series, but I think you probably know the way I did in class, a little bit different than most textbooks do it. So I'm going to write this down, and this is number 52. I go back to white. So 52. And what do I have? I have 1.2, and the H7 is what's being repeated. So my recommendation to you is to get the repeating pattern. So what I'm going to say is, I'm just going to say X is 1.287, and I'm going to multiply X by 10, just so I see the repeating pattern. And what would you get? 12.87. And let me repeat this. The H7 keeps repeating itself forever and ever and ever. Now what I'm going to do is multiply both sides by 100. We'll do that in a second. And I'll multiply this side over here by 100. Now, someone says, why are you doing that? It's going to move the decimal 2 places. So what do you get over here? 1, 0, 0, 0. What do you get over here? 1287.87. All right, and that H7 repeats itself forever. All right, right below this, I'm going to write 10x is the same thing as 12.87. I'm going to subtract, and what do you get? 990x. You may wonder what I'm subtracting. 1000x, I'm taking away 10x. Now I'm taking the 1287.87 repeats forever, and I'm subtracting away 12.87. Well, what's nice about that, all those repeating decimal places just cancel right off, which is good news for me. I didn't like that repeating anyway. So what do you get over there? Let's take a look at it. You certainly get 1, 2, and let's see, you get 5 there and a 7 here. All right, let's keep going. I think I can put X down now. What's X? X will equal 1275 over 990. All right. Now, by the way, I like the answer. I actually prefer to see this answer because it's easier for me to, look at it. But I want to point out most textbooks would not like that answer. So what I want to do is I want to briefly go through it with you. And I want to talk about, what I would do, basic grade school arithmetic. I know both top and bottom are divisible by 5. Put that down for you. So the bottom one divided by 5, I'm sorry, the top one divided by 5 is 255. Let's do the 990. I'm going to divide that by 5. Did I make a mistake there? 990, let's see, 5. Ooh, I see the mistake. I'm sorry. The reason I see a mistake, I'm seeing 138. I wasn't expecting. I expect to see something that was at another number in it. And I apologize that I made a mistake in my arithmetic. Part of it's not thinking. All right, let me start again. And that's a good lesson to learn. If you're not getting what you expect, you probably made a mistake somewhere. So let's see, 1, this would be 5, and then I get 4. Before I wrote down 1, it's crazy. So, what times 5 give 49? There's no number, but I'm going to say 9 times 5 is 45, right? And what do you get there? Did I do that right? 9, 5, 4, 9, 990, 45, 40, and 8, 198. All right, let's look at it. And I'm looking at that. I'm wondering, can that be reduced more? And I sure the numbers are small. And I'm going to say this looks like a great answer to me. But I want to keep going, right? And so this is why do you want to keep going? I want to see if there's another number that divides into that. And I'm going to say, 5 was obvious, the first one. Now I'm looking at it and I'm saying 5 would not go in both of those numbers. So I'm going to move on to another number. Certainly 2 wouldn't go in. They're not even. The bottom's even, but the top's not even. But I'm going to say 3. And I want to talk about the divisibility rule for 3. If the sum of the digits is divisible by 3, the number is divisible by 3. What's the sum of the digits on top? 12, and that's certainly divisible by 3. How about on the bottom? You get 18. That's divisible by 3. So I'm going to write this down for you. 255, I'm going to divide that by 3. And what do you get? 8, 24, 155. Let me write that down for you. Now I'm going to divide 3 into 198. And again, I know some students can do that in their head. Fair enough, do it in your head. 6, that's 18, 18, another 6, so I get 66. Now, by the way, I'm going to say that looks like a good looking answer. And if I looked at 85 and 66, I'm going to 66 is 6 times 11. And let's see, let's do the 85. I'm going to say 5 times something, right? 5 times what? Well, let's see, that'd be 10, 17, right? By the way, they have no factors in common. That's 85. So this is my final reduced answer. That's my final answer. That's the polite answer. That's the answer you want to aim for. But I got a box on all those. They look good to me. They're all good to me. Let's look at the K. And I'm expecting to see 85 over 66. And lo and behold, I see 85 over 66. Let's go to 53. And 53, I'm going to pull this one to the side. Whoops, I did a mistake there. Sorry about that. And I'm going to push this over here. Let me blow this up. Okay. They want me to use summation notation for this. And this can, I'm not saying it's going to be easy for you, but the first thing I do is realize the terms. So the first term is 3 to the 1. The second term is 3 squared. The third term is 3 cubed. That's 3, 4, plus yada, yada, yada. And I'm wondering, is 729 a power of 3? Right, I don't know. Let's see what happens. I'm going to say, if I did 3, 4, 3, 5 would be 243. You wonder how I did that. I did 81 times 3, got 243. What's 3, 6? Oh, I know, Bob, there again, 600, 720, 729. So it's going to be 3 to the 6th power. Now, someone says, what's the missing term? There's only one term missing. How many terms are there? I'm counting them up for you. 1, 2, 3, 4. Remember, 5 would be there, right? 3 to the 5th, 3 to the 6th. How many terms? 6 terms. Let's write the summation down now. All right. So this sum is going to equal 3 to a power. I'll call the power I. I starts at 1. Let me point that out to you. And then it goes to 2, then it goes to 3, then it goes to 4, then it goes to 5, and it ends at 6. Write that down for you. This is the summation notation. All right. Let's look at the K. And when you look at the K, my emphasis is look at the K. Now I use the letter N instead, but it's really the same thing. I just use the letter I in my answer. Same thing. All right. Let's go to let's go to problem number 54. And number 54 says, write the expression so that it's not in fractional form. And certainly, someone says, what are your goals here? My goals are to rewrite it. All right. So I'm going to, play around with it. And what I would probably do is write everything to the sines and cosines. It may not work though. And what I mean by that, this could go in a dead end. But if I don't move, I am in a dead end. So sine squared x over cosine squared x. That's not so bad. And this would be 1 over sine x plus 1. All right. So this is what are you going to do? There's many things you could do. I'm kind of looking at it. And I'm going to, maybe, I don't know. That doesn't seem like it's really helped me out too much, does it? So I'm going to try maybe multiply by conjugates, see what happens there. All right. Let me erase. Again, there's nothing wrong with that. But I'm going to say, it just looks too complicated. So I'm going to, turn sines, cosines, but I'm going to try something a little different over here. I'm going to multiply the bottom by its conjugate. And its conjugate is cosecant x. Whoops, that doesn't look right. Minus 1. I'm going to multiply the top by cosecant x minus 1. My goal really is to multiply the bottom now, not the top. And the top is going to be tangent squared x times cosecant x minus 1. And the bottom side, because the conjugate, what do you get? Cosecant squared x minus 1, which is a Pythagorean identity. All right. Let me just briefly go through that with you. And I'm going to write down the Pythagorean identities for you. Sine squared theta plus cosine squared theta is equal to 1. You could divide both sides by, by sine squared, and you would get 1 plus the cotangent squared theta equals the cosecant squared theta. Whoops, sorry. And I could write down cotangent squared theta is cosecant. Whoops, I get really excited here. Sorry about that. Cosecant squared theta minus 1. And I realize some students say, I'm much faster than you, and you should be. All right, but I like to go slow. And sometimes you're going really too fast for me. You got to get your own speed though. All right. So I'm going to write the bottom down as a cotangent. And what's the top? Tangent. And what do you get over here? Let's see. Cosecant. Oh, I'm sorry, I wrote the bottom down incorrectly. I got to change that. Got theta in my brain. All right, I'm going to keep rewriting it. They do not want a fractional form. And be honest with you, I am done because I can write now, 1 over cotangent squared is tangent squared. So would that give me? Tangent to the 4th power x times cosecant x minus 1. So I'm saying in all reality, that's a good answer. It's no longer fractional. All right, now someone's got to go further than that. Let's give it a shot. I'm going to go back to the fraction. I'm sorry, fourth power. And that doesn't look too productive, does it? I'm really back in the same loop. So I'm going to say you could multiply that out, but it's not going to be a good thing to do. All right, so let me erase that. I'm going to accept that as an answer. Are there other ways to write it? Yeah, there are, but let's just say it there. And let's go to the next page. All right. And let's see what they did. Well, they did a little bit differently. And let's see what they've done. And this is nice because I'll be honest with you, on exams, I often see different answers down, which is great to see them down. And they wrote something different down. And to be honest with you, I like the answer I wrote in the prior page. But you realize there's variance here. So I want to point out what they have over here. Their answer is this guy over here. That's not in fraction form. I actually like the answer put in the other page better. All right. But it's really the same answer. It's not a different answer. There's no fractions in it. All right. Let's take a look at number 55. I want to claim on exams, unless, WebAssign gives you a calculator, I would say, don't use a calculator on exams unless WebAssign's feeding you a calculator. This is going to require the use of a calculator, though, and I'm going to just pretend. Sorry about that. I'm going to pretend that I have a calculator at my disposal, but I don't. All right. The first thing I want to mention in 55, the first thing I would do is draw a picture of it. And let's put that down for you. Again, when I put a picture down, I'm not saying my pictures are terribly accurate, but I'm going to say this is side A. And what's side A? 13.25 inches. All right. And I'm going to say side B is 7.28 inches. And side C is 9.02. Well, I'm going to try to ballpark that. And I'm not saying I'm doing a great job. But, when I say ballpark, I can't really say I'm doing a great job of ballparking it. But I'm going to say this now is side C, 9.02 inches. And side B is going to be 7.28 inches. All right, I think I copied everything okay. This is angle B, that's uppercase. This is angle A, it's uppercase. And this is angle C, that's an uppercase letter. I'm going to say that the angle I want to go for is I want to go for the angle A. And I'm going to pretend I have a calculator to do that because I'd hate to do this by hand arithmetic. All right, and what am I going to use? Law of cosines. I'm going to aim for the big angle first. And what's that going to be? A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Let me go through that work for you. That's going to be A squared minus B squared minus C squared is equal to minus 2BC cosine of A. We'll put the numbers in later, by the way. All right, how do you do that? I can divide both sides by minus 2BC. And what would you get? Let's write this down. You would get C squared plus B squared minus A squared all over 2BC is equal to the cosine of A. All right, what am I going to do now? Arc cosine of this crazy thing over here would equal the angle A. Right now, so I don't think I could do that. And I think you can. And what I mean by that is you could certainly take a calculator out now, right? And what are you going to do? You would take C and you would square it. You would take B, you would square it and take away from C squared. And you would take A, square it and take it away. So I'm going to say that's doable. And then you would divide by 2. Then you would divide by B. It's written over here. And then you would divide by C. And then you hit the arc cosine. And I'm going to claim if you did that, you're going to get the number that we're telling you you're going to get. Now, someone would say, what happens if I can't get that number? You come by during office hours and we'll discuss it with you. We can lecture, look at what you're doing. We can show you how to do this in Sage too. So let me underline that for you. You should get this number over here. All right. Then someone says, how would you get B? Well, I would store A in the calculator. So I would store this as a variable in a calculator. So I would store it. And then I would use the law of sines, I'll write this over here, to get the other angle. Now, what angle would you go for? Either B or C. I'm going to go for B. So sine of B, I don't know B, by the way, but I do know side B is equal, I'm going to circle what I'm looking for. I'm looking for this, is equal to the sine of A, which I know, it's sort of my calculator, over side A, which I also know. Let's write this down. So sine of B would equal B times sine of A over A, and B would equal the arc, push this over, oops, sorry about that, arc sine of B times sine A over A. And yeah, you need a calculator. Again, I want to point out, you know B, it's right there. You know A, it's right there. And A has now been stored in your calculator, and you could certainly do the sine of A. Make sure, though, that you're in degree mode, because we like to answer these problems in degree. And then after you do this computation over here, which would be B times sine A divided by A, hit the arc sine function, and you'll get B. Again, my claim over here is you'll get B. You'll get it. I mean, I kid you not. But let's say you say, I still can't use a calculator. I'm at the end of the semester, and I've spent no time learning my calculator. Come by during office hours. All right, you can turn your camera on. You can show me your calculator. I would much rather use Sage, though, to do it. And we could go through that during office hours, too. All right, we've done a lot of Sage in class. So my claim over here, if you did the B, whoops, I'm sorry, I'm going all over the place. You'd get this. Then the question is, how would you get C? Well, that just couldn't be any easier. And why is that? C would equal 180 degrees minus A minus B. And if you did that in your calculator, you get that number. Let me point out what number you're going to get. You're going to get this number over here. All right. Again, if you have trouble using your calculator, come by during office hours, and we'll be more than happy to help you with it. And I really mean that. But we want you to move forward. And if moving forward is learning a calculator use, you know what? That's not a bad thing to learn. All right. So I'm going to go to number 56. And 56 says, given, and let me blow this up a little bit. It says given, PK is this, put down PK plus 1. Well, it couldn't be easier. So P, oops, sorry about that. P, K plus 1. Look at the formula. Wherever you see K, put K plus 1. Wherever you see K, put K plus 1. This is a fine answer. I'm going to simplify it, though. Do not feel obligated to do so. That would be 5K plus 5 minus 3 is plus 2. And if you want to write this further simplified, K plus 1 times 5K plus 2 over 2. I want to point, look at the answer. This is the answer we're looking at. Let's go to the next page. That was easy. 57 says find the sum. Well, that looks pretty easy to me, and I'll tell you why. It's a fraction problem, and I certainly know how to add fractions together. What's common denominator? 12. What times 3 gives you 12? 4. 4 times 2 pi is 8 pi. Plus, what times 4 would give you 12? 3. That's 3 pi now. Plus pi. And what would that give you? 8, 9, 10, 11, 12 pi over 12. And I can reduce that, and that's pi. All right, let's go to the next one. Next one's a vector problem. And I'm going to, certainly I'm looking at it. I see U, I see V, I see W, and they want the angle between U and V. All right, put this on the side for you. And again, I want to go through that formula that you may not be able to remember. It's a formula that we derived, a while ago we derived it, that the cosine of theta, and that's the angle between two vectors U and V. That's the angle theta they're talking about, is U dot V over the length of U times the length of V. That's a formula you should know. So let's put this down. And certainly I'm looking at U and V. I want to point out what I mean by that. I'm looking at those guys. And let me just point that out to you. This is U and this is V. And I think I could do U dot V. What's that going to be? 1 times 5 is 5. Plus minus 5 times minus 3 is 15. We'll do that later. What's the length of U? It's a root problem. And what's that going to be? Well, 1 squared is 1. And minus 5 squared is 25. And again, we'll do that later. What's the length of V? 5 squared is 25. And when you square minus 3, you get 9. All right, let's write this down. So cosine of theta is equal to 20. And what do you get on the bottom? The root of 26. That's a nasty number, isn't it? And this is going to be the root of, let's see, 25 and 9 is 34. Okay. Someone's going to say, what do you do now? I'm going to try to simplify it. And someone says, why? Well, I'm going to have to eventually use a calculator because I couldn't do that in my head. I'll put 20. I'm going to look at this, and I'm going to go back to what you learned in Math 100, all right? Root 26 times root 34. Well, 26 is 2 times 13. And 34 is 2 times 17. So what notice about this over here? Root 2 times root 2 is just 2. And root 13 times root 17, there's no perfect square over there. Let me do the arithmetic for you, though. 130, 21, and 70. And what's that going to give you? 221. This reduces to 10 over root 221. I'm going to get my eraser out because, that's arithmetic on the side. I really don't need to see that. And let me erase it. And we'll look at our answer key later. What do I want? I want theta. And what's theta going to be? Arc cosine of 10 over the square root of 221. Now, again, I need a calculator to do that, and I don't have a calculator with me. So I'm going to trust my notes. And if you did that in notes, you get about 47, 48 degrees, all right? I do want to point out, though, I'm not really interested in the approximate answer for that, but you should learn to use a calculator, and that's A. So we just did A. That's looking good to me. Let's go to B, and I'm looking at B now. And B says the length of U minus W. And this one looks much easier for me to do, all right? So the first thing I want to do, and I'll put this down over here, equals the length of U minus W. I'm looking at it. So U minus W. So that's going to be 1 minus a minus 3, which is 4, comma, minus 5 minus a minus 6, which would be 1. And what's the length of this thing over here? The root. 4 squared is 16. 1 squared is 1. It's root 17. Got that done. All right, let's do this one over here. 5W, well, that's easy. It's a scalar multiple. Minus 15, comma, minus 30, plus 3V. What's 3V? 15 and minus 9. What do I get over there? Oh, that's 0. When I add those components together, minus 39. All right, I'm seeing the answer. All right, this is good news. Okay, this is a dot product. And what's the dot product going to be? Well, I'm looking at W and V. So what's it going to be? V dot W, so that's minus 15, plus minus 3 times minus 6 is 18. And will this give me 3? All right, I'm seeing everything is necessary. Let's go to the next thing. They go through some Sage code over there. This is Sage code over here. And you're more than welcome to look at the Sage code. This is Sage code. Again, it's going to bode well for your future if you're moving forward in STEM to look at that. All right. And again, we discussed that before. Let's look at 59. 59's it's a reminiscent problem. We've seen these before. And that's what review is. It's stuff that we've seen before. And let me just make sure you know what we're going to do over here. And I know I probably, talk about this too much, but I want to point out the invertible region of the tan function. And I'm going to put this down for you. Let me go back to white. Is this region here. That's the invertible region. And that goes between minus pi over 2 and pi over 2. And what do I know about the cosine curve between that? The cosine curve between that is always going to be a non-negative number. So that's good for me. Right? And that means I can start using right triangles now. I think I'll write this down for you. So the cosine of this, and we're going to talk through that using a right triangle. And I'll put this over here. And I'll put the theta down. I want to point out this is the theta. What do I know about theta? I know the tangent of theta would be x over 1. Pythagorean theorem for the hypotenuse would be x squared plus 1. What's the cosine of that theta? 1 over the square root of x squared plus 1. Again, look at the k and you see that answer. All right, so we just finished 59. I'm going to go to 60 now. All right. Again, sometimes I want to use a formula. I'm not opposed to use a formula. I'm still going to think through the problem. Whoops, I just did another error. Just give me a second. And what I'm going to do, I'm going to write it down for you. So this sum, whoops, I'm going to go with the white. This sum is going to be 0. I'll break this over. This is an infinite sum. Is 0.9 to the first power plus 0.9 to the second power plus 0.9 to the third power plus yada, yada, yada. Goes on forever. What I'm going to do is I'm going to multiply both sides by 0.9. What would I get? 0.9 squared plus 0.9 cubed plus 0.9 to the fourth power plus yada, yada, yada. All right. What I'm going to do, I'm going to subtract them now. So I'm going to say this is one of these minus 0.9. What are you going to get? 0.1 times s infinity. That was easy. Now, of course, the other side is subtraction is a little more complicated. It could be very misleading, by the way. But what do I notice about it? I notice if I'm subtracting, there's an awful lot of disappearances. A lot of things just disappear. And what we left off with? 0.9. All right. What am I going to do now? I'm going to divide both sides by 0.1. And what would you get? S infinity. Well, 0.9 divided by 0.1 is just 9. And certainly we're getting that answer. I want to point out what they did. They used the formula. And the formula is going to be A1, which is 0.9. I'll write the formula down for you. And that would be 1 over 1 minus the common ratio. That's R. All right. I'm sorry, I put the ratio. I'm sorry, I shouldn't have done that. All right. And what do you get there? You just plug it in. A1 is 0.9, 1, and the common ratio is 0.9. What do you get over there? 0.9 over 0.1. Whoops, I did it again. And that would still be 9. All right, formula or thinking, get the same thing each time. All right, 9. The answer is there for you. You might be surprised calculus can do that as well. So that was number 60. And let's go to number 61 now. All right, load us up. And I'll talk through it. All right, so what I notice over here, it's a deja vu problem for me. I'm almost positive we did this one before. They all look the same to me though. And what do I got over here? It's a trigonometric equation. And there's going to be a lot of solutions to this equation over here. At least I hope there is, right? It'd be pointless to solve an equation with no solutions in it. Not pointless, but at this level it would be almost pointless. We want to see your techniques over here. So what do you do over here? I say convert things to sines. So the first thing I would do is 2, and cosine in terms of sines is 1 minus sine squared x. And then we get plus 3 sine x minus 3 equals 0. I'm going to push this up. And what do you get over here? 2 minus 2 sine squared x plus 3 sine x minus 3 equals 0. Let me make sure it's minus 3 there. Yeah, it is. Let's keep going. This is minus 2 sine squared x plus 3 sine x. And 2 minus 3 is minus 1 equals 0. I'm going to multiply both sides by minus 1, and that's going to be 2 sine squared x minus 3 sine x plus 1 equals 0. I'm going to try to factor it. And by the way, if this is not factoring, I'd probably say I made a mistake somewhere. We write problems are really easy. We do. Let's see if we get that. 2 sine squared looks good. Let's see, minus 2 minus 1 is minus 3. That looks good. Yeah, it looks good. So I'm going to say over here, this is fairly simple. And what do I mean by that? For the second factor, for this to be a true equation, the sine of x would have to be 1. And this over here, for this to be true, the sine of x, when I say true, the product is equal to 0, the sine of x would have to be a half. So I'm going to draw my picture. I'm going to talk about it. I'll put this over here. That's one cycle. Does the sine function ever equal 1? Yeah. And what does it equal 1 at pi over 2? I'm going to write that down for you now. X equals pi over 2 plus, it keeps repeating itself, every 2 pi, with the understanding it's going to be a multiple of some integer. What's k? K is any integer at all. All right, that's a Blackboard notation for integer. Let's do a half now. And what's a half? Half is like this, and hits it twice. I got to figure that out now. And the way I do that, I look at a reference triangle. And a reference triangle for that would be this over here. And I hope you recognize that. That's 30 degrees, right? So what's my first angle? Again, I'll get to the radian measure later, but the first one's between 0 and 90 degrees, and that would be a 30-degree angle. All right, well, what's the next one going to be? The next one's going to be in the second quadrant between 90 and 180 with a reference of 30, so it's 150 degrees. All right, let's write this down now. So x is, well, what's 30 in radian? That's going to be pi over 6, right? Plus 2 pi k. What's 150? Well, it's 5 times 30, so it's 5 pi over 6 plus 2 pi k. All right, let me box this as an answer. Whoops. All right, we're going to get the next page and we're going to look at the answer now. All right, make sure I did this. Yeah, it's going to be on the next page. Let's see if you can retain that. Pi over 6, 5 pi over 6, and pi over 2. I'm seeing it. That's good news. All right. All right, let's take a look at number 62. And I want to see if I can do it. All right. It's a sum problem. And, one thing nice about sums is you can, kind of split them up. But I got to be honest with you, splitting it up at this stage of the game, that's going to be too helpful for you. What I'd like to do is just simply start writing the terms down. All right. As I do that, I'll write one term down at a time. So it's going to be 2 times 48 minus 1 plus 2 times 49 minus 1 plus 2 times 50 minus 1. I think you get the idea what I'm doing, right? You know, plus yada, yada, yada. What would the last term be? 2 times 70 minus 1. So someone says, I wonder what that is. You know, certainly you look at it, I have no idea what it is, but I think we could write this down and maybe like a different order. All right. So then the question becomes this, how many terms are there? And some people are often funny. They say, oh, there's 1, 2, 3, 4 terms. No, there's not 4 terms. It starts at 48 and goes to 70. Let me write this down for you. So the number of terms is upper minus lower plus 1. Let's see if we can do that. What's 70 minus 48? Well, that's 22, right? And 22 plus 1 is 23. So there's 23 terms. So what I'm going to do is I'm going to write this down for you now. Now, if there's 23 terms, I hope you realize there's 23 of those minus 1s. Right? I'll write that down for you. Every term has minus 1 in it. Now, what's left over? 2 times 48 plus 49 plus 50 plus yada, 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 up to 70. All right, again, we're just thinking through the problem. I know it's difficult, but we're just thinking through it. That's all we're doing. All right. So I'm going to say the first guy's pretty easy for me, right? Just minus 23. The second guy, a little more complicated. I want to point out, what is it? It's an arithmetic series where the first term, right, is going to be 48. And the last term is 70. And let me write this down for you. So for an arithmetic series, what do? It's going to be, let's write this down for you. N times A1 plus AN over 2. Well, let's write this down now. What's N? Well, it just is 23, right? Push this on the side a little bit. I'll put this over here. We'll do the arithmetic later. What's A1? It's 48. What's AN? Is 70. All right. What's the bottom 2? All right. Kind of getting crazy looking, but I'll see if I can do the arithmetic. Minus 23. We'll look at the key later. Plus, well, I hope you realize the 2's cancel off. Plus what now? Well, let's write this down. 23. And gee, what's 48 plus 70? That's going to be 118, right? I'll do the arithmetic now. What do you get? I'm going to factor out 23 minus 1 plus 118. I'm not beyond making mistakes, by the way, and that's why I want to look at the key later. I'm going to do the multiplication. I'll write this down for you. 3 times 7 is 21. 3, 5, 3. 2 times 7 is 14. Let's see, 2. Sorry about that. I lost track what I was doing. 14, 1, 2, 3. And then 2, 1, 9, 6, 2. So this is going to be 2, 6, 9, 1, unless I made a mistake. Let's take a look. Wow. Got it. All right. Let's take a look at the other one. And it says approximate nearest tenth, the arc length of a circle, radius 14. Again, this requires a calculator, but I want to point out the formula for you. And the formula is S equals R theta, with the understanding that theta is in radian. Okay? So S is the arc length, R is the radius. So it says approximate nearest tenth, the arc length of a circle, radius 14 inches. I'll write that down. And we got to get the arc length, that's S. But the problem is the angle is 60 degrees, but it must be in radians. So 60 degrees times pi over 180 degrees. And what's that going to give you? Pi over 3. So what's theta? Pi over 3. What's S going to be? Let me write this down for you. S is going to equal 14 pi divided by 3 inches. They want you to approximate it, use a calculator, and you should get this number over here. Again, for the students having trouble with a calculator, come by and see me. We'll help you out with it. I really mean that. We want to help you. We don't want to throw you over the edge and say it's not important. It is important. All right. And 64 is déjà vu. I do want to put work down for you, but I'll go through the work over here. Common denominator. What goes in the numerator? 1 plus sine x. Because I'm multiplying by 1 plus 1 minus sine x. What happens over here? Well, look at the top. You just get 2. But again, the bottom, 1 minus sine squared. All right. Now, someone says your work looks different. It doesn't matter. I'm looking at the answer in the end. So I'm looking at students' work, so that looks different too. Some of this is wrong work, but the bottom line is we want to get the work down. And what's going to be 2? What's 1 minus sine squared? That's cosine squared, isn't it? Pythagorean identity. And what's going to be 2 secant squared? All right, done. Next one, find the exact values in both degrees and in radians. No, we do not need a calculator to do these problems over here. I'm going to remind you how I do them. And the way I do them is I look at the invertible region of the cosine curve, and I look for the ratio 1 over root 2, and I know the reference for that. The reference angle would be 45 degrees. So what's the angle? 45 degrees, that's the degree measured. What was in radian? Pi over 4. Certainly seeing that. All right, let's do this one over here, a little more complicated. I got to do the sine of 5 pi over 3 first, and I think I can do that. I'm going to write this down for you. 5 pi over 3 times 180 degrees over pi. Well, the pi's cancel off. That's not bad. 3 goes into 180, 60 degree time. 5 times 60 degrees, 300 degrees. So if I were to visualize that, the angle looks like this. And that's going to be 300 degrees. What's the reference going to be? 60 degrees. Well, what's the sign of that? If you thought about it, it's minus root 3. I'll write that down for you. So it's going to be arc cosine of minus root 3 over 2. All right, now what do you do? It's really back to the same old story. I'm looking at the arc functions, and what am I doing? I'm looking at the cosine. Looks like this. And where does the ratio minus root 3 over 2 happen? Over here. So I know it's between 90 degrees and 180 degrees. And the question is, what's the reference for that? All right, well, I'm going to look at the cosine curve, and the cosine curve, I'll put this down for you. This would be, and again, I'm doing a reference triangle. Let me get my eraser out. It doesn't look right. And this would be 1. And this would be 30 degrees, right? So what's the reference? The reference is 30 degrees. So what's the angle going to be? Well, it's between 90 and 180 with a reference to 30. It's got to be 150 degrees. Let's write that down in radian. Shouldn't be so bad. I'll write this over on the side for you. Well, that would be 15 over 18 pi. And I'm starting to realize there's by 3, right? So it'd be 5 pi over 6. That's done. All right, let's see how we're doing. At 65. And again, don't be discouraged. Now, I know it's a lot of work. Review is always a lot of work. You might say, I can't remember anything I've learned. You may not be studying enough if you can't remember. By the way, I always say that memory is kind of short term for most people, but the more you work at something, the more long term it becomes. All right. Now, what do they want to do? They want you to find a period of this function. All right. Kind of looking at it, and yeah, it's got sines and cosines in it, right? And I'm going to say this thing repeats itself a lot. Let's take a look at it. And I'm going to look at this thing. This might be a tough question for some, so no doubt about it. And let's take a look. All right, so it's kind of a mixture of things, isn't it? And I got two things going on here that keep repeating themselves over and over again. Let's see if I can do something special with this guy. And I'm looking at it. Now, I know there's two contributing factors here. So the period of each one separately, okay? What's the period of this guy over here? Well, it begins at 0 and then ends at 1. What's the period of this thing over here? Well, begins at 0 and it ends at 2. All right, so period of this one is 1. And the period of this one is 2. All right. Now, certainly, I'm going to say that that period of 1 occurs twice in that period of 2. That doesn't bother me so much. That first guy, this guy here, occurs twice in that second guy. But I'm really wondering, how long does it take the second guy to complete one cycle? And he definitely wins out in the game for the period. This guy is determining the length. So what's the period? The period is 2. Okay, I want to briefly go to Sage. I'm sorry, not Sage. I want to briefly go to software. And again, this is part of your learning curve. You want to go back and say, gee, I wonder if that's true. And I'm going to do another share with you. And what I want to do is make sure I'm sharing the right screen with you. Give me 1 second. I apologize. Yeah, we're doing okay. So we're on this one over here. Go look at my clock. And we're getting the problem number 66. Wow, we're really sailing along in this thing over here, right? 66. And what I want to do is I want to just go through, and you just, again, this is part of your learning curve. This is something that you want to be doing. You don't want someone else, oh, they've done it for you. You want to do it. And I'm going to go to Grapher. Again, when I use Grapher, that doesn't mean you have to use Grapher. Use the applications you like using, including your cell phone. I'm going to graph this out. So sine 2 pi x. And remember, I set that at a period of 1. And I want to point out to you that looks like this over here. That thing repeats itself every length of 1. All right. Now, what I'm going to do is I'm going to do the other one for you. And the other one is 2 cosine. And I set that at a period of 2, right? That's pi x, isn't it? Let's take a look at that. I want to see that as a period of 2. Like I said, well, beginning to end. Yeah, length of 2. I see it. I see a length of 2. Let's combine them up. See what happens. All right. So 2 sine 2 pi x plus. Let's look at this. Zoom out a little bit. And I'm just going to, zoom into a region that I think is going to show me, whoops, sorry about that. I'm going to be zooming into a region that I want to show you the period of it. So when I'm looking at it, I want to point out, maybe I'll zoom out a little bit more. If I were looking at this thing over here, I'm going to say, there's definitely a repetition. Like if I started here and I kind of move along, you see what I'm doing? And the question is, what's that length? What's that length? What's the length between that, beginning? What I'm saying beginning is to the end of it. Well, I'm going to pick an easier one, an easier interval here. I'm going to pick these guys over here. I'm just looking at it. I'm looking down over here. It's about 0.2, looking at my scale. You see that? 0.2? 0.2, 0.4, 0.6, 0.8. I'm going to say 0.2. And what's this one over here? Well, this looks like 2.2. And what's the length between those crests? 2 units long, as we said it would be. Okay? So let me go back to my notes. Again, it's important you start using technology to help you learn. Get back to the whiteboard. And I'm going to go to number 7. Boy, this is old stuff, man. So 67. So our recommendation to you is pick a side. And the side I'm going to pick is this side over here. And then what I'm going to do is I'm going to rewrite this side until it looks like the other side. And let's go through that. All right. And the way to do that is many ways to do it. But I'm thinking to myself, it's probably the simplest thing I could do is just rewrite this as secant squared theta over secant squared theta minus 1 over secant squared theta. Let me keep going. The next line. What's secant squared over secant squared? Well, conditionally, it's 1. We're not worried about the conditions. Conditionally, it's 1. Minus, what's 1 over secant squared? It's cosine squared. There's something wrong with my pencil. It must be wearing out. Let me just fix it, okay? I got to sharpen my pencil, so to speak. What's this thing over here? It's just sine squared. QED. We're done. We show what we're supposed to show. All right? All right, number 68. Find the equation of the parabola with focus, directrix, y-axis. I'm going to pull it on the side for you. This is, I'm going to say, relatively new. It's in the recent past. But again, you may not be able to remember that. Maybe you haven't studied hard enough yet. What I recommend you do is draw a picture. All right, so I'm going to draw a picture of it. And when I draw a picture of something, I'm not going to say it's a great picture, but it's good enough for me. X-axis, y-axis, okay? Where do they say it? It says a focus at 3, 4, right? Let's put that down. 1, 2, 3, and then 4 up. That's the focus. It says a directrix is the y-axis. Put that down. Well, now I know where the vertex is. And how do I know that? I'm looking at a picture. So I'm going to write the vertex down for you. And the vertex is going to be along this axis of symmetry. I'm going to put the axis of symmetry in for you. Again, this is directrix. The axis of symmetry looks like this. And I know I've got a vertex that's centered between the focus and directrix. All right, that's not so bad. It's right about here. So I can write the vertex down for you. And what's the vertex going to be? Let's take a look. It looks like 1.5. That's in between 0 and 3, by the way. So what's 1.5? It's 3/2. What's the y coordinate? Well, it's 4. That's pretty simple. I got that. Now, I'm going to put that other thing down. And what's that? It's like the 4p, right? 4p. So what's the p? Well, I'm going to look at it. And I want to remind you what the p is. Let me point this out over here. It's that distance over here. All right. And what is that? Well, it's going to be, well, maybe before I do that, because it could be plus or minus, right? So I'm going to put this over here. That this is a parabola that opens like this. Focus on the inside, right? Something like this over here. So the P is clearly positive. I'll write that down for you. And that distance between the vertex and directrix and the vertex and the focus is going to be 3/2. So I'm ready to write it down. And what's it going to be? Let me write it down for you. So it's going to be y minus k squared equals 4p x minus h, with the understanding that hk is the vertex. Let's write this down. So y minus 4, we'll look at the key later, squared 4p x minus 3/2. Let me just clean it up a little tiny bit. And sometimes I don't want to clean it up. You could leave that. It's a good answer. I do want to clean it up. Let's see, you get 6, right? X minus 3/2. Let's see, y squared minus 8y plus 16. 6x minus, let's see, 3, 9. Wow, it's going to be a lot of work. So I guess I could write down, this is another good looking answer. No fractions in it. And you could rearrange that. Let's go back to the key though. Let's see how we did. All right. What did they do? Well, they got this one down. That's clear as day. All right. Make sure you said, yeah, it is. They got another one down. Now, what did they do over here? They rewrote a little different than I did. Y squared minus 8y. They added 9 to both sides would be 25 is equal to 6x. That's the answer they have written down. All right. So it says, what's the best answer? Well, the correct answer. I mean, there's many correct answers. This is correct. This is correct. This is correct. You could rewrite this differently too. It's still going to be correct, provided you're doing correct things. All right. What number is that? 68. Let's go to 69. Let me look at my clock. And we're going to close it at 69. Then we'll come back next time and finish it up. I know it's long though. And that's what you take. Take some pieces, little tiny pieces over here. Find a standard form. Oh, ellipse. All right. Foci. Well, I think you know what I'm going to do. Draw a picture. Not a great picture, but a picture. So it says standard form equation of an ellipse, given characteristic, foci plus or minus 4. That's along the x-axis. Right there. They're the foci. And then it says major axis length 12. What does that mean? Well, I got vertices over here now, and it's 12, so it's going to be 6 in from the center, and this is the center. That's 12 units long. What does it look like? This over here. Ah, boy, it looked really bad. Let's write this down. Center is going to be 0, 0. The vertices is going to be, let's see, 6, 0. And the other vertex is going to be minus 6, 0. Well, I noticed there's an equation of an ellipse, so I'm going to write it down. It's going to be x squared over something plus y squared over something. And why is that? The center is really easy. It's going to be, x minus h, y minus h squared, but that's 0, 0. And it's going to equal 1. But I know a point on this thing over here. And it says x is 6 or minus 6. So this has to be 36. And I'll tell you why that is. This is 0. It disappears. If you got plus or minus 6 here, this would be 36. And 36 by this is 1. Now I got to get this thing over here. And this is a struggle for a lot of students. So I'm going to write the C down for you. What's the C? The distance from the center to that foci, and that's going to be 4 units. All right, well, let's write this down then. So C squared is going to equal to 36 minus, well, I'm going to call this thing A squared over here. Now, by the way, somebody says you can't call it A squared, you get to call it B squared or something like that. You call it what you want. Just don't call it X or Y or C. I'll call it A squared. So what's C squared? It's 16. Let's keep going. Let's see if I can figure that out. Let's see, this is minus 20 equals minus A squared. And A squared would be 20. I got that figured out. My eraser out. We'll look at the key later. I'll erase that.
and I'll put 20. Let me look at the answer key. I really mean that. Look at the answer key. And I'm hoping you're realizing we've got the same answer they got. All right, we come back next time. I'll start up with 70 and move forward. I realize this is a very long review for some students. The more time and effort you put into your studies, the easier life is going to become, at least in your study department. Okay, thank you.